last class we have discussed about projectile. Projectile is an object which is projected initially at an angle or horizontal. There are two types of projectile, horizontal projectile and at an angle. Anyway, projectile is an object which is projected initially with a velocity and thereafter travels under the influence of gravitational force, under the influence of gravity. A stone which is thrown at a velocity, whether horizontal or at an angle. Anyway, we can say just after it is released from your hand, that travel under the influence of gravity. Or an arrow which is shot from a bow, or a bullet fired from a gun. These are all examples of projectiles. Okay,
that are horizontal projectile, right?
Horizontal projectile means if you're throwing horizontally, it will fall like this. Is it clear? This is a horizontal projectile.
Yes.
That means it's
So
downward velocity. Same thing.
Like
which how you project. For example, if you're holding a bow like this and firing, so this is a projectile at an angle theta.
Sir, horizontal projectile, like yesterday you gave that. Yeah, sir, that horizontal projectile, yesterday you gave the coin example, right?
So, yes, an aeroplane bombarding some place. So once it is released, suppose aeroplane moving with 100 meters per second, the moment it released, it has only horizontal velocity 100 meters per second. If there is no gravity, then there is no friction of air, this bullet, this bomb will go along with the flight, no need of any fuel. If there is no opposition of air, if there is no gravity, how fast this bullet aeroplane goes or flight goes, same speed, this will also go along the same direction. Okay. Since gravity, it's coming down like this. That means initially its downward velocity 0. After 1 second, it would cover 5 meters down, just like a freely falling body. Isn't it? That we already calculated. A freely falling body, if it is dropped, first 1 second, 5 meters it will cover, then 15 meters it will cover, then 25 meters it will cover, then 35 meters it will cover. That we calculated. U plus V by 2. Every 1 second, 10 meters per second increase in velocity, this will gain. So this is a property of projectile that last class we discussed. Now I will show you one animation about it. When one more thing, look, when this is x-axis, this is y-axis, when it is projected with the initial velocity u at an angle theta, this can resolve into two components. Its horizontal component we are marking as u cos theta. U cos theta. Here friction of air neglected. Then all the time it will cover same distance horizontally. U sine theta. At the time of releasing, it will be u sine theta. Okay. Here distance covered in 1 second. When this is covering a distance, okay, in this direction in a time t, horizontally how much it will cover, vertically how much it will cover. That's a question. Okay. So horizontally it will cover x is equal to u cos theta into t, if this is t. Vertically it will cover y is equal to u sine theta. Formula I'm using, s is equal to ut plus half gt squared. There's a formula. For vertical motion, initial velocity u is equal to u sine theta, and time to reach here. Same time it will reach here also. That is t minus half gt squared. Here,
sir, it's minus or plus?
This is minus because g is always downward, okay, according to Cartesian coordinate system. And this is u cos theta into time. Okay. So 1 second, how much it will travel vertically, that you will get from here. 1 second, how much it will travel horizontally, substitute here. These 2 points, if you join, you will see in this direction how much object traveled. This is a basic concept. Clear? So when the object is reaching here, this vertically, it will move this much. Horizontally, it will move this much. Clear? And just like a freely falling body, same thing will continue. And here its velocity, how much? Same velocity it will gain here also. With what velocity it went up here and here, with the same velocity, it will hit on the ground here. This way. Is it clear?
Yes, sir.
Yes, sir.
So this is a basic concept. Now I'll show an animation based on this idea. Listen carefully. Okay? Yes. Very useful. many just note down FENDT dot D bar HTM 15. This diagram shows a projectile. Okay, look here. I am putting a slow motion now. Okay, first we have to reset and take initial height 0, initial speed, angle, everything we can set here. Now look at this one. Okay, start. Look how it's going. Okay, now I'm resetting. Again, you look here. While it was going here, you see one red line was moving along the horizontal direction. That shows horizontally how much that object is covering. At the same time, vertically one line is there. That shows vertically how much it's going. Okay, look here now. Once again. Now it reached maximum height. You see, this vertical line, you see maximum height it went. This is horizontal position. Agreed?
Yes, sir.
Yes, sir.
But horizontally it covers, but vertically it comes down back. You see, so vertical displacement is 0. Horizontal displacement is not 0. Is it clear?
Yes, sir.
Yes, sir.
Now you can make it fast. Okay, this is the actual motion there. See here, this much fast it goes. So anyway, you can, if you want to observe it slowly, put your option slow and reset there and start. You see, so very clearly you'll understand two motion. Actually, object is traveling along this trajectory, but it has same time horizontally it's covering, vertically it's covering. Until maximum height, vertically it will go. Horizontally it will go. After reaching maximum height, horizontally it will cover further same distance. Vertically it will come down to the same place. So we can say throughout the motion, this is called time of flight. Whole time it comes in air and reaches back to ground. This is called time of flight. So during the time of flight, this vertical displacement is 0. And if you want horizontal distance, you cos theta into time of flight you have to take to find out horizontal distance.
2.5.
Sir, if you activate velocity, they will show the actual arrow.
I will show you. I will show you. Now velocity. See, I will show you. Everything is there. This shows, see, velocity. This along this angle, that's a velocity. Look at the angle. Clear. At same angle, it will fall here. You can see that now. Okay. Now I'm starting here. It's already resolved. Horizontal velocity, vertical velocity. While it is moving, you can see vertical velocity decreasing. Horizontal velocity remains same. While coming down, again vertical velocity increasing, horizontal velocity remains same. You see that, okay? I'm putting slow motion here. Look here. Maximum height, see? Vertical velocity 0. That's why it could not go further up. But still horizontal velocity they show. That means it can go forward again, okay? Look at that. Now vertical velocity started, see? So this angle, you check what was the angle with the horizontal when it started, same angle it comes here. That means if you throw javelin throw, right? You're playing in the sports, that one at an angle, if you throw, same angle, it will come and fall. But friction of air should be neglected. Is it clear? Right.
Yes, sir.
Easy
Yes,
once
sir.
again. So this idea should be clear hereafter. See, now it's starting. Vertical velocity becomes 0, vertical velocity comes down. See, initially how much it gets, same thing. Is it clear?
Yes, sir. Sir, what about acceleration?
I will show you, I will show you. Now angle I will show here, okay? Angle I will change.
So shouldn't the vertical
60
velocity
degrees.
be 5 when it is hitting the ground?
Vertical velocity?
Should be 5 meters per second when it is hitting the ground, right?
It will be 5 meters per second. Same thing, that angle. At an angle, resultant velocity will be 5. Okay, now you look here. This I change angle 60. You see now angle 60. Now look at the range, horizontal displacement, you check. See,
The
same angle. it
acceleration
forms.
is always acting downwards, right?
I will show you that. Let us finish one by one. When I'm speaking about velocity, listen to that. Then we'll think of acceleration. Now you see here, it comes here, same angle. You see 60 degrees started here, 60 degree ends here. You understand? But range decrease.
Yes, sir.
Okay. Now I'm taking here 30 degree. First I kept 45 degree. Okay.
Yes,
Look
sir.
here, this is 60. Look at the point, 2 point something, right? 2 point something.
Yes, sir.
Yes.
Now 90 minus 60 you take. So 30 will come, right?
Yeah.
Yes,
Yes,
sir.
sir.
Look here now. 90 minus 60, how much it will come? That means 30 degree.
Around 3.
Reset, start. Same place, you see? It's falling in the same place.
Yes, sir.
Do you understand? Range decrease, but same place. That means 30 degree and 90 minus 30, it will fall in the same range. You can try this. Kitchen, water tap, if you open, you keep a pipe and keep this one, protractor. 30 degree, you keep the pipe, you can see water falls someplace. And 90 minus 30, you take 60 degree. Again, it will fall in the same place. This is applicable in conventional wars. If you go to African borders, that Eritrea, Ethiopia, and all know, sometimes war is going on, they are still using these cannons. So there with the angle, they are adjusting to fire the range. So maximum at 45 degree only maximum range will come. More than 45, less than 45 range will decrease. One thing to notice. See, here I am keeping 45 degree angle. Listen carefully. Huh? Here I am keeping 45 degree angle. Look at it, look at this. 45 degree, reset. We can see maximum range. 2.5 something. See, maximum range it goes. Now more than 45. Degree? 120 means it will go reverse side, right? It will go the left side.
Sir,
then you have to take 90 minus 30 to this side we have to go.
Sir, 15 degree and 75 degree same range.
Yeah, I'll show you. I'll show you. You tell me. Now see maximum 45. Now you tell me what you want. 15.
Yes, sir.
Oh, 15 degree check. Reset. Sorry. 15 degree. 15 degree. Okay. Reset. 15. Start. See, here it falls. Now you want 90 minus 15, 75, right?
75 degrees, sir.
Let us see, 75, how much it will come. That's what you can take it and like a game, you can check it. Reset. See, same place it falls.
So, sir, it's theta and 90 minus theta, it gives in this, it falls in the same position.
There's a proof. We have to prove it. Theta and 90 minus theta. That maths, how it plays here, it's very interesting. That means suppose you want to hit at this point in a war. So 15 degree if you're keeping, there may be a building. So that bomb may go and hit on the building. You want to go it above the building and fall onto the same place.
75 degrees.
Then you keep 75. It will go above the building and fall and hit the same place. See how physics works? It's interesting.
Yes,
isn't it? Yeah.
Yes, sir.
Yes, sir.
So this is one thing. Now, next one is the acceleration. Now you understood, right? So 45 degree,
yes,
we
sir.
get maximum range. So first anybody asked, giving say for example 6 kilometer, using this particular projectile, can we hit 6 kilometer? Somebody asked, then you don't have to bother about it. You have to just check at 45 degree where it can hit. If the range they told you, beyond that range we obtained by 45 degree, then that place you cannot hit. Less than 45 degree, by adjusting the angle we can hit. Is it clear?
Yes, sir.
Yes, sir.
Right. Now, next one. Now let us bring to this 45 degree. Okay. Here you see now first one. Position once again you check here.
Angle.
Angle. Okay. 45 degree. 60 degree, let us try, so we'll get little height for this. Once again, check. Look at how it's going, horizontal vertical displacement. This is now displacement, horizontal displacement, u cos theta, vertical displacement, u sin theta, into that formula, S is equal to ut plus half it square. That formula I told you.
Yes,
Next
sir.
one,
Yes,
reset, velocity we have seen, then acceleration, you see. Acceleration downward, right? The object is here, acceleration due to gravity downward.
Yes, sir.
Now you see throughout the motion, that is downward. See, it's downward all the time. Is it clear?
Yes, sir. It's clear.
Yeah.
Yes, sir.
Now energy, this all very clear. Energy and all same thing. No need. This much part only we have to understand here. Any doubt in this?
No, sir.
No, sir.
No, sir. Now look at the site and you can check whenever you like. You can just we are going back to our theory part. So yesterday we have written, a projectile is an object projected initially with a velocity and thereafter travels under the influence of gravity. Next paragraph. When an object is projected, when an object is projected,
Sir, is this the question?
No, we have to write about in introduction about a projectile, because after 1 or 2 months, you must know what is it when you read. Isn't it? Otherwise you will forget. When an object is projected with initial velocity u, when an object is projected with an initial velocity u, at an angle theta, with the horizontal. So while doing numericals, you should consider angle with the horizontal. Sometimes to confuse you, they will give the angle with the vertical. We'll do that kind of numericals. Then you have to take 90 minus theta and substitute. Here all derivations we are making with an angle theta with the horizontal. Okay, so initial velocity u at an angle theta with the horizontal. Then velocity can be resolved. Into its rectangular components. Velocity can be resolved into its rectangular components. That is u cos theta along x-axis. And u sin theta along y-axis. Okay, so this is resolution. You should know clear. Resolving a vector. Draw the diagram.
Sir,
that is u cos theta along x-axis and u sin theta along y-axis. If this is the initial velocity of the projectile at an angle theta, then u cos theta is acting along velocity of u cos theta acting along x-axis and u sin theta acting along y-axis.
Sir, should we draw the graph as well?
Yes. Draw the diagram. And this is a path.
Yesterday we drew, sir, this graph.
Oh, if you have drawn yesterday, no need to draw again. Okay. This is vertical velocity. This is horizontal velocity. At this point, this vertical velocity will decrease. Now you might have understood that part. This is decrease now. Yes. So you have to take less length. But this one, same length you have to mark here. See, same length will come here. This is not changing. Now this point at maximum height. Horizontal velocity again remain same. Vertical velocity 0. Then at this point, exactly this point, downward, right? It is?
Yes,
it is
sir.
downward.
Yes, sir.
Vertical velocity downward. Same length it must be. Then this one, that remain here, constant here. Okay. And while hitting here, vertical velocity.
Sir, the graph is same for position
Downwards.
and velocity.
Yeah. Position means you have to multiply by time. That's all. When it's reaching a time, t, then you will get x. Clear? That's the only difference.
Yes, sir. Okay.
It is no. Same angle theta will come here. So this is u y. Okay, this we can write uy. This is ux. ux. So this point, this is uy. We can say this is uy. Here uy is equal to 0. At maximum height, uy is equal to 0. Here uy downward minus negative is again uy downward. So this green line indicating just like how a vertical motion. If horizontal velocity is not there, this will go same height and fall the same way.
Yes.
Clear? So vertical velocity and horizontal velocity has no influence here.
Sir, uy while going down, we don't have to mark that negative sign, right?
That's see, since it's marked down, I am not marking.
Okay.
Isn't it? Otherwise, again, if I'm putting minus, that means it's up. Minus of minus. So it's already showing downward, then you don't have to put minus again. According to Cartesian coordinate system, you know it's minus. Clear? This is ux. Ux here, ux, 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 ux. Now, if you want x here, u cos theta into time. That means here if you want, take that time. Here if you want, take that time. Here if you want, take this time. Clear? Did you understand?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir. Got it.
At this position, if you want, take the time to reach here. At this position, this time you plot here, then you can see this position. Here it will come y is equal to u sin theta into t minus half gt squared. Using this formula only, we can calculate this moment because that is accelerated motion. Here, friction of air neglected. Friction of air neglected. Now all basics are over.
Sir, where is friction of air?
That means if you throw a paper, light paper or feather, this all will not work out. But a shot put or a bomb we are firing, such cases friction of air is negligibly small. Clear?
Yes, sir.
That's what we are saying, friction of air neglected.
Yes, sir.
Now, if friction of air is considering, then ux is not constant. It will, what happened, decelerated. Then range won't be this much distance. Range will reduce. Continue now. Next para. During the motion of the projectile, its vertical motion is determined by u sin theta component. If u sin theta component is more height it will go. That means if angle during the motion of the projectile, the vertical motion, its vertical motion is determined by u sin theta component. And horizontal motion is determined by u cos theta component. Horizontal motion is determined by u cos theta component. That means if angle is 45 degree, almost same, it's equal, right? Both sides. Horizontal component and vertical component. But if angle is more, then vertical component will increase. For example, angle is 60 degree, then this component is more. So this will go more height. If angle is less than 45 degree, then horizontal component is more. So it will go less range.
So what component? What is the component?
Vertical component. Vertical component depends on
vertical component.
A vector, right? In vector, if you are throwing it at an angle, say for example 10 at an angle 60, horizontal component 5 meters per second, vertical component is 10 sine 60. Around.
Component means I didn't get.
Suppose this is projecting with an angle, with an angle 30 meters per second, for example 10 meters per second, isn't it? That means in 1 second 10 meter travel, right?
Yes, sir.
Now horizontally, what will be its position? When it reaching here, horizontally, from ground at an angle 45 degree, it moves, for example. Okay?
Okay.
This is the horizontal ground. From here, I am projecting an object with a 10 meter per second at an angle 45 degree. Okay. After 1 second, how much distance here it travel? This travel 10 meter in this direction. Along this, it travel 10 meter. That's the meaning of 10 meter per second. But horizontally, how much distance it travel? From here, if you draw a line, from here, how much distance it will go? That's called horizontal component.
Okay, sir, I got it.
How will you find out that? If this is u, we can say u cos
theta
45. How much vertically it will go? Isn't it?
U sin theta.
That depends on not u sin theta, sy is u sin theta, the component, minus half gt squared. Then only you will get vertical distance.
Okay, sir, I got it.
S is equal to ut plus half at squared. This is a formula, isn't it? Here I am not taking, it is not accelerated, no gravity in this case we consider. Any doubt?
No, sir, thank you.
So if an angle is more vertical height it will go, because vertical component will be more, so more height it will go if angle is more. That's the meaning of it. Any doubt?
No, sir, thank you.
Okay, fine. Now you want me to draw the diagram again? You have the diagram with you, right?
Yes, I have it.
Now complete it, otherwise it will take more time. Complete it. So during the motion of the projectile, the vertical motion is determined by u sin theta component. Look at your diagram which you have. U sin theta component. And the horizontal motion is determined by u cos theta component. Horizontal motion is determined by u cos theta component. Next paragraph. During the motion of the projectile, the vertical component of the velocity decreasing. During the motion of the projectile, the vertical component of the velocity decreasing. Vy, keep decreasing. The vertical component of the velocity is decreasing until it reaches the maximum height. Until it reaches the maximum height.
The vertical component
of the velocity decreasing.
Sir, can you repeat it again?
During the motion of the projectile, the vertical component of the velocity decreasing. We have seen in that projectile animation, right?
Yes, sir.
This vertical component is decreasing here. And finally, at the maximum height becomes zero. Vertical component of the velocity decreasing until it reaches the maximum height. And the vertical component increasing during its downward motion. During its downward motion. While horizontal velocity remains constant. Horizontal velocity remains constant.
Sir, until it reaches the maximum height.
And vertical component increases during its downward motion. Increases during its downward motion. But horizontal velocity is constant throughout the motion. Horizontal velocity is constant throughout the motion. Horizontal velocity is constant throughout the motion. If friction of air is neglected. If friction of air is neglected. If friction of air is neglected. Is this over?
Yes.
Yes, sir.
Yes.
Next heading, it's a proof. Usually they ask this question in the exam. Prove that path of the projectile. Path of the projectile. Path of a projectile. Or we can say trajectory. trajectory, path and trajectory, same thing. Trajectory of the projectile is parabola. Is parabola. Prove that path of the projectile, path of a projectile or trajectory of a projectile is parabola. We are going to prove it. Look here. See, what is the formula for parabola? In maths, there are some equations developed for circle, straight line, parabola, hyperbola. You must have drawn that graph, or you may be learning this year. I'm not sure about it, which class you are studying. Anyway, look here. This is the formula for parabola. Y is equal to ax plus bx squared. Here a and b are constant. For example, you can plot a graph here. Okay? Here you take x and here you take y. Okay? A and b are constants. A and b are constants that we can fix. In this case, for example, suppose this is 2 and this is 3, for example. And x value put 1, here put 1. Then you get y. X value 2, 2, you put y. 3, 3, you put y. Like that, you get 10, 15 readings and plot a graph. You can see your graph will come almost like this. That means a parabolic shape will come. That's the specialty of this formula, ax plus bx squared. We are going to prove equation for a projectile will be ax plus bx squared. And time, if you substitute, you can see a graph comes like a parabola. That's what I'm going to explain now. Okay, look here.
Yes, sir.
Look. So this is y axis. This is x axis. Okay, y, x. Here we are projecting. We are projecting a projectile with an initial velocity u. Okay, its initial velocity u. This projectile now reached a particular point in a time t. For example, if it is projected with the 10 meter per second, in 1 second that will reach 10 meter from here, right?
Yes, sir.
Now its horizontal distance it covered, if you want, that we call x, isn't it? X. I told you that x
Yes,
we
sir.
can calculate it as u cos theta.
U cos theta t.
Yeah. And vertical component you can calculate as y is equal to u sin theta minus
half
gt
gt
square.
GT square.
So here 1 you substitute, here 1 you substitute, then you will know x and y. Actually object here at the point P, where bracket I am marking xy, sorry, xt.
Sir, u sin
Okay.
theta into t should be there, right?
U sin theta t. U sin theta t. Sorry. Y is equal to u sin theta into t minus half gt square.
GT square.
This is u cos theta into t. But actually object is here. Okay. Here this is the intercept x and y. X you will get here, y you will here. It happens at an instant of time t. Any doubt?
No, sir.
No, sir.
Now look here. From here, this projectile will travel and it will fall here in the form of a parabola. This is what we are going to prove. Path is a parabola. First, I am taking vertical component. Y is equal to u sin theta into t minus half gt squared. After a time interval t, this is the vertical displacement of the object. And horizontal displacement is u cos theta into t. Now from this t, I'm going to substitute here. T is equal to x divided by u cos theta. This equation number 1, this equation number 2. Now substitute the value of t in equation number 1. Y is equal to u sin theta into, what is t? X by u cos theta. Okay, then minus half into g, what is t? X squared divided by u squared cos squared theta. Any doubt up to here? This t
No,
I
sir.
substituted here and here.
No, sir.
No, sir.
No.
Oh, sir.
Now this u cancel. Sin theta by cos theta is tan theta. Okay, sin theta
Yes, sir.
by cos theta is equal to tan theta. You should know that by heart. Okay. So that will be tan theta
x.
Tan theta of x minus half g divided by u squared cos squared theta into x squared. Get it out? Suppose theta is 45 degree here. Theta 45 degree. Then tan theta is 1, right? Tan 45 1.
Yes, sir.
So for a given projectile, this value is constant. If theta
Yes, sir.
fixed, g is constant, u is constant, theta is constant. Only x and y are changing, isn't it? So here we are assuming let a is equal to tan theta. Let tan theta is equal to a and minus half g divided by u squared cos squared theta is b. Look here, this is a and this much portion is b. It's a constant for a given projectile, isn't it?
Plus b.
Get it out?
No, sir.
No, sir.
Then we can conclude the answer. Look here. Then final answer. Y is equal to tan theta is ax, isn't it? Plus,
Yes,
because
sir.
minus already I have taken here. That is b x squared.
X squared.
So a we can calculate from this data tan theta. B we can calculate from here. Substitute a and b and x 1 meter, 2 meter, 3 meter like that you put. You will get y. Plot a graph. Your graph will be a parabola.
Parabola.
This is the proof. Is it clear?
Yes, sir. Yes, sir.
This is the
Yes, sir.
expression.
Yes,
This
sir.
is the expression for parabola. Hence, it proves that a projectile is traveling along a parabola. Right. Draw it out. If any part you don't understand, tell me. Can I start?
Yes, sir.
Let us consider an object. Let us consider an object is projected. Let us consider an object is projected with an initial velocity u. 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 At an angle theta. At an angle theta. With x-axis. With x-axis. At an instant of time t, at an instant of time t, during its journey,
Sir, initial velocity u.
let us consider an object is projected with an initial velocity u at an angle theta with x-axis. At an instant of time t, at an instant of time t, the projectile is at the point P. At an instant of time t, during its journey, we imagine a point at an instant. At an instant of time t, the projectile is at the point P, where its horizontal component,
Projectile is
at the point P, where its horizontal component, that means if you make a x-intercept, where its horizontal component is x is equal to u cos theta into t. X is equal to u cos theta into t. And the vertical component, is y is equal to u sin theta t minus half gt squared. Y is equal to u sin theta t minus half gt squared.
sir, and vertical component.
Vertical component y is equal to, it's written, u sine theta into t minus half gt squared. Then write once again. Y is equal to u sine theta t minus half gt squared, where g is acceleration due to gravity. We have to explain every symbols. Where g is acceleration due to gravity. Then x is equal to u cos theta into t. Then t is equal to x by u cos theta. T is equal to x by u cos theta. Equation number 2. Substituting t in the previous equation. Y is equal to u sine theta. T is x by u cos theta minus half g. T squared is x squared divided by u squared cos squared theta. Finish it. Step, please ask.
Yes.
This is the expression for, so here y is equal to ax plus bx squared, and we have written this is the expression for parabola. Have written?
Yes, sir.
Yes, sir.
So very important derivation. If you study today, you will learn. Tomorrow, if you try to learn, you will forget. Remember. So today itself, finish this work.
Yes,
Next. Next one. Expression for maximum height.
So
Next
this is
derivation. Next derivation. Expression for maximum height traveled by a projectile. Expression for maximum height traveled by a projectile. So when we throw a projectile, we know it has a horizontal component and vertical component. Which component of the velocity decides the object to travel maximum height? Is it horizontal component or vertical component?
Vertical.
Vertical component. So we have to think about only vertical component here. Look here now. So here, look here. If we throw an object at an angle, say for example, this is theta, it will travel this way and fall here. So maximum height, this is the maximum height it traveled, isn't it? Maximum height.
Yes, sir.
Yeah. This factor decided by S is equal to, or Y formula, Y is equal to U sine theta, isn't it? Sorry, maximum height, right? Yeah. At maximum height, vertical velocity Vy is equal to 0. But horizontal velocity is not 0, isn't it?
Yes, sir.
Do you follow?
Yes, sir.
Yes,
So
sir.
this vertical motion can be treated like this formula. V squared is equal to U squared plus 2GS. Same formula we can use. Because vertical motion is similar to a body going up and coming down. Maximum height, its velocity 0. Any doubt?
No, sir.
Yes, sir.
Initial velocity is U sine theta, right?
Yes, sir.
U sine theta whole squared minus 2G. S is maximum height it traveled. Now we can write 2GH is equal to U squared sine squared theta, and H is equal to U squared sine squared theta divided by 2G. That's all. Clear?
Yes, sir.
Yes, sir.
Yeah. That means a body which is thrown vertically up is nothing but a projectile with an angle theta 90. Then U squared by G will come formula.
So I have a doubt. So why did you take V square equal to U square plus 2GS?
This formula where we are applying for uniformly accelerated motion, right?
Yes.
Its vertical motion is uniformly accelerated. Am I right?
Yes.
So I can use this formula there. This formula we have developed to apply for uniformly accelerated motion, right?
Yes.
The motion of the projectile along vertical direction is uniformly accelerated. Because 5 meter it will cover, then 15 meter it will cover, then 25 meter it will cover, 35 meter it will cover, and change in velocity 0, 10, 20, 30, 40. So it's accelerated motion, right?
Yes.
So this formula I can apply there. Agreed?
Yes.
Agreed.
Velocity v, 0, maximum height. Vy is equal to 0. That's what v is equal to vy here. And u sine theta, because it's projecting at an angle theta with a velocity u. This u, if you resolve, this will be u cos theta. So that factor only deciding initial velocity upward direction. That's what u sine theta is substituted here. Minus, this is being pulled by gravity g. H is a maximum height it went. Any other doubt?
No,
No, sir.
No, sir.
Write down maximum height. I think next class we'll write this note. It is time for it. Okay, it's time for today.
Sir, can we copy this derivation?
Next class we'll do, no problem. Anyway, we have to solve.